point to one specific general phenomenon in the body that underlies aging?
Yeah, well, that's contentious because, scientists like to come up with new hypotheses. It's how they build their careers. But fortunately, during the 2000s, we settled on 8 or 9 major causes of aging. We called them hallmarks because causes was a little bit too strong. But these 8 or 9 causes, at least for the first time, allowed us to come around and talk together. We put them on a pizza, so everyone got an equal weighting, equal slices. I think that there's one slice of the pizza that is way larger than the others, and we can get to that. But that's the information in the cell that we call the epigenome. I actually ended up boiling aging down to an equation, which is the loss of information due to entropy. But this equation really represents the fact that I think aging is a loss of information in the same way that when you Xerox something 1,000 times, you'll lose that information, or you try to copy a cassette tape, or even if you send information across the internet, some of it will get lost. That's what I think is aging. And there are 2 types of information in the body. There is the genetic information, which is digital, A, T, C, G, the chemical letters of DNA. But there's this other part of the information in the body that's just as important. It's essential, in fact, and that's the systems that control which genes are switched on and off, in what cell, at what time, in response to what we eat, etc. And it turns out that 80% of our future longevity and health is controlled by this second part, the epigenetic information, the control systems. I liken the DNA to the music that's on a DVD or a compact disc. For the younger people, we used to use these things.
I recall.
Yeah. And then the epigenome is the reader that says, okay, in this cell, we need to play that set of songs. And in this other cell, we have to play a different set of songs. But over time, aging is the equivalent of scratching the CD and the DVD so that you're not playing the right songs. And cells, when they don't hear the right songs, they get messed up and they don't function well. And that is what I'm saying is the main driver of aging. And these other hallmarks are largely manifestations of that process. That dictates which genes are switched on and off. And when we're developing in the embryo, the cell marks the DNA with chemicals that says, okay, this gene is for a nerve cell. You cell will stay a nerve cell for the next 100 years, if you're lucky. Don't turn into a skin cell. That would be bad. And those chemicals, there are many different types of chemicals, but one's called methylation. Those little methyls will mark which songs get played for the rest of your life. And there are other marks that change daily. But in toto, what we're saying is that the body controls the genome through the ability to mark the DNA and then compact some parts of it, silence those genes, don't read those genes, and open others, keep others open that should stay open. And that pattern of genes that are silent and open, silent, open, is what dictates the cell's type, the cell's function. And then the scratches are the disruption of that. So genes that were once silent, and you could say it's a gene that is involved in skin, it's starting to come on in the brain, shouldn't be there, but we see this happen. And vice versa, the gene might get shut off over time during aging. Cells over time lose these structures, lose their identity, they forget what they're supposed to do, and we get diseases. We call that aging. And we can measure that. In fact, we can measure it in such a way that we can predict when somebody's going to die based on the changes in those chemicals.